In this video, we're going to be looking at some examples of solving a system by first converting it to an augmented matrix and then using our elimination method. So let's take a look at this first example. We can first convert it to an augmented matrix. That's going to look like the matrix 1, 1, and then we put our vertical line to represent that equal sign, 3, and then 2, minus 1, 3. So the first step we might do here is taking row 2 and subtracting 2 times row 1. That becomes the matrix then 1, 1, 3. 2 minus 2 is 0. Negative 1 minus 2 is negative 3. 3 minus 2 times 3 is 3 minus 6, which is negative 3. We might then take row 2 and divide by negative 3. This now becomes 1, 1, 3. 0, 1, 1. And then one more step, we might take row 1 and subtract row 2. So this becomes 1 minus 0 is 1, 1 minus 1 is 0, and then 3 minus 1 is 2, and then 0, 1, 1. There's no more elimination we can do. At this point, we want to just be able to go back and read off the solution to our system. And so I'll remind you that this first column represents the coefficients of the variable x in our system, and the second column represents the coefficients of the variable y. This vertical line is representing our equal sign. So that first row in this last matrix here basically says that 1 times x, which is just x, plus 0 times y equals 2. So we get that x equals 2. And this second row says 0 times x, so I'm not even going to write that, plus 1 times y, so just y equals 1. And so we get our solution to this system, x equals 2, y equals 1. In this example, we've got 3 unknowns and 3 equations. So let's start by, again, writing that augmented matrix. That's going to look like 1, 1, 1, vertical line, 2, and then 2, 2, 2, 2, and then 1, minus 1, 1, 1. So our first step would be to do R2 minus 2R1 and R3 minus R1. And we're going to go over sort of how I know what to do and when to do it in kind of videos later on. But for now, we'll just go through a few examples. So this matrix now becomes 1, 1, 1, 2. Our second row becomes 2 minus 2 is 0, 2 minus 2 is 0, 2 minus 2 is 0, and then 2 minus 2 times 2, so 2 minus 4 is negative 2. And actually at this point we can sort of stop, since kind of reading back what this second row tells us at this point. Remember that, again, each of these columns represents the coefficients of x, y, and z, and then we have our equal sign. So this second row at this point says 0 times x plus 0 times y plus 0 times z, which is just 0, equals negative 2. And no matter what we plug in for x, y, and z in all these equations, this particular fact will never be true. So if we get a situation where we're row reducing and we get something like this, where it's 0 equals some non-zero number, then we can stop and we know that this particular system has no solutions. Let's do one more example. This example has 3 equations and 4 unknowns. So the augmented matrix is going to end up being a 3 by 5 matrix that looks like this: 1, 1, 1, 1, 2, 2, 3, 1, negative 1, 1, 3, 4, 2, 0, 3. So our first step might be to take row 2 and subtract 2 times row 1, and then row 3 minus 3 times row 1. So this matrix becomes 1, 1, 1, 1, 2. 2 minus 2 is 0. 3 minus 2 is 1. 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. 1 minus 4 is negative 3. In our third row, we have 3 minus 3 is 0, 4 minus 3 is 1, 2 minus 3 is negative 1, 0 minus 3 is negative 3, and 3 minus 2 times 3 is 3 minus 6, which is negative 3. Next step, could take row 1 and subtract row 2, and row 3 and subtract row 2. So this becomes now 1, 1 minus 1 is 0, 1 minus negative 1 is 2, 1 minus negative 3 is a 1 plus 3, so that's a 4, and then 2 minus negative 3 is a 2 plus 3, which is 5. Second row stays the same, 0, 1, negative 1, negative 3, negative 3. And now our third row, you might notice, is actually identical to our second row. So when we do this subtraction, we're going to get all zeros. And if you think back to that previous example, you might be getting a little worried. When we got all zeros before, we ran into a situation where we had no solutions. The difference there, however, was that we had a non-zero number to the right of that vertical line. Go back to that example so you can see that, right? So this second row says 0 equals negative 2, which was what led to this no solution situation. We don't have that same thing here. Instead, our third row now says 0 equals 0, right? 0 equals 0, 0 equals 0, not 0 equals 1. This says 0 equals 0, which is totally fine. 0 does equal 0. No matter what we plug in for those variables, 0 will equal 0. So that's actually okay, and does not tell us that we have no solutions. And so we are fine to sort of continue solving this system. We are actually at a point now, and again, this is something we'll go over later in the course, how we'll be able to tell this, but we're at a point where we have no other elimination to do. And so we can write out our solution, or at least attempt to. So our first row, well, let's first actually just remind ourselves. So this first column is the coefficients of x1, x2, x3, x4, and then that equal sign. So this first row says x1 plus 0 times x2, so I'm not going to write that, plus 2 times x3 plus 4 times x4 equals 5. And that second row says 0 times x1 plus x2 minus x3 minus 3x4 equals negative 3. And so we're actually in a place now where we have infinitely many solutions. And one way to describe that set is by all of the values for x1, x2, x3, and x4 that satisfy those two equations. We're going to, kind of as we progress in the course, come up with other ways of describing solution sets when we have infinitely many solutions. So, one thing we'll see is that we can talk about this idea of free variables and defining free variables and then defining all of our other variables in terms of those. But for now, we'll just kind of note that we have infinitely many solutions and they all will satisfy these equations.